Okay, so for this problem, we're trying to find the magnetic field at the center of a current loop with a current of 10 amps and a radius of 2 meters. So when we're trying to find the magnetic field at a point due to a current running through a wire, we want to use Biot-Savart Law. So let's write that down. We have dB equals mu naught I over 4 pi times ds cross r hat over r squared. So first thing we can do is figure out actually the direction of the magnetic field using our right hand rule. If we put our thumb in the direction of the current and curl our fingers outward, we see the magnetic field is going to be coming up outward through the middle of the loop. So the magnetic field is going to be in the positive z hat direction. So now we just need to find the magnitude of the magnetic field. So let's take the magnitude of this. Magnitude of dB is going to be equal to mu naught I over 4 pi r squared times the magnitude of ds cross r hat. And that is going to be equal to 4 pi r squared magnitude of ds times the magnitude of r hat, which we know is just going to be 1, times the sine of the angle between them. Let's figure out what that is. So if we're considering a little element of our wire, ds, that vector ds is going to be tangent to the wire, and our r vector is going to point from our little wire element towards the center of the loop where we're evaluating the magnetic field at. So r hat in this direction is going to be 90 degrees from our ds vector. So this is sine of 90. Thus, dB is just going to be equal to mu naught I over 4 pi r squared times ds. Now, what is this r squared here? This is the magnitude of our vector from the line element to the point we're evaluating the magnetic field at. But we're evaluating it at the center of the loop. So the magnitude of this vector is going to be our radius of the loop. So let's change this to big R. So now we can calculate our magnetic field by integrating this. So B is going to be equal to the integral of mu naught I for 4 pi r squared ds. And we're going to integrate from 0 length to 2 pi times the radius, the full length of the loop. And that is going to give us mu naught I over 4 pi r squared times 2 pi r, which is just mu naught I over 2r. So now we can plug in our numbers. Mu naught is 4 pi times 10 to the minus 7 times the current, which is 10 amps, divided by 2 times the radius, which is 2 meters. And if you plug that into your calculator, you should get pi times 10 to the minus 6, and magnetic field is measured in units of teslas. Now this is the magnitude of our magnetic field, and we already figured out it's going to be pointing in the positive z hat direction. So writing this in vector notation, we have the magnetic field at the center of the loop is going to be pi times 10 to the minus 6 teslas z hat.